60. So Tom is now clearly 25 plus, so 50 plus 10 is 60, and so Tom will be 25 plus 10, 35. So Tom is now 35, his mother is 60. So the ratio of their ages is 35 is to 60. So we could solve it. Using both the statements together, we could solve it. So we pick option 3. Question 40. What is the length of the sides of the square? Statement A. Area of the largest circle that can be inscribed in the square is 154 square centimeters. Statement B. The diagonal of the square is longer than the length of the sides by 3 centimeters. Using statement A alone, from area of the circle, we can find the diameter of the circle, which is equal to the length of the sides of the square. From the area of the circle, largest circle that can be inscribed in the square. So the radius of the circle is half of the length of the side of the square. So from the area of the circle, so that is pi r square, right? So using the formula, phi r square is 154. So we can solve for r. We know the radius of the circle. And the radius of this circle, largest circle inside the square, is nothing but half of the length of the side of the square. So we can find out the length of the square. So this statement alone is clearly sufficient. So we're using statement B alone. The sides of the square, the diagonal of the square is longer than the length of the sides by 3 centimeters. So there's a square and the diagonal is greater than the length of the side by 3 centimeters. So we know the ratio between the diagonal of a square and the side of the square, right? Diagonal is square root of 2 times the side of a square, right? Because x square plus x square equals diagonal square. So 2x square equals diagonal square, and so diagonal is square root of 2 times the side of the square. So diagonal is approximately 1.41 times the length of the side of the square. So and we also know that, you know, if you square them, so basically it's like square root of 2 times x minus x equal to 3. So that's what it means. And if you can solve, square it, okay? So diagonal is greater than the side by 3, right? So x plus 3, the whole square, is nothing but 2x squared. Just square it because it's easier to solve. And solve this equation, okay? So solve the quadratic equation to find x. So I'm saying either way, this using B alone, we can solve for the value of the length of the side of the square. So either statement alone is sufficient. So we pick option 2. Question 41. Who is the youngest among John, Peter and Tom? When Peter was 6 years old, Tom was 3 years older than the average age of Peter and John. So 3 guys, John, Peter and Tom. When Peter was 6 years old, Tom was 3 years older than the average age of Peter and John. So looking at the statement, don't be inclined to think that Tom was older than Peter. We don't know. Let's say the average age of Peter and John was, you know, like 3 years or, you know, less than that. We can't have less than that because even if John was 0 years old, the average would still be 6 and Tom would be 3 years older and he would be at least 6 years old. Yeah, anyway, we'll analyze it later. So we have the statement, and then statement B. John's age is equal to the average of the 3 friends' ages. So using statement A alone, we don't know if John is older than Peter. If John was minimum 1 year old, so what is the minimum age that John can have? 1 year old, right? I mean, generally there's nothing like 0 years old. So if John was minimum 1 year old, so Peter was 6 and John is 1. So average of Peter and John would still be 6 plus 1 divided by 2. That is 3.5. Tom was 3 years older than the average of Peter and John. So if the average was minimum 3.5, Tom was 3 years older. So he would be 3 years older than 3.5. So Tom would be at least 6.5. So Tom will be anyway older than Peter. Okay? So Tom is older than Peter. So Tom is clearly not the youngest. So between Peter and John, we have to find out who is the youngest. So if John is older than Peter, we consider a situation where John is like the minimum age. If John is older than Peter, then the average would be greater than 6, right? 6 and say 7. So their average would be greater than 6. And Tom would older than 3. So either way, Tom is older than Peter. But John may be younger than Peter, or John may be older than Peter. We don't know that. So a John or Peter, either of them could be the youngest. So statement A alone is clearly not sufficient. Using statement B alone, we cannot. So John's age is equal to the average of the three friends' ages. John's age is equal to the average of the three friends' ages. So we cannot infer who is youngest. So John's age is equal to the average of the three friends' ages. So it's possible that all three of them are of the same age, or it's possible that Tom is older, Peter is younger, or Peter is older, Tom is younger. Either of them is possible. So we still can't infer. So either statement alone is not enough. But using both together, so John is equal to the average of the three friends' ages, right? So substitute John's age as, say, John plus Peter plus Tom divided by 3. Okay? That's John's age. So when Peter was 6 years old, how old was John? John was Peter plus John plus Tom divided by 3. So 6 plus 6 plus j plus t divided by 3, and you take the, so when you're calculating the average age of Peter and John, substitute John's age as the average of the three friends' ages, and then you take the average of that, and when you find that particular value, it will be in terms of Peter's age, and using that you can say Tom is still older than Peter, and using that particular equation we can determine that Peter will be the youngest. Response question. So basically the average of the three friends' ages, right? So we know using both these statements that Tom is older. So John is the average of the three friends' ages. So Tom is older. So if Peter and John were the same age, then the average of the three cannot be John's age, right? The only way you can have John's age as the average of the three friends' ages is when Tom is older and Peter is younger. Only then John can be in between, he can be the average, right? They're not all three of the same age. One is older. So only when the other one is younger, John can be in the middle, right? Average. So using both together, we can say Peter is the youngest. So both the statements together, we can say, so we pick option 3. So question 42. What is the length of the edges of the cube X? So statement A, the surface area of a cube Y, whose volume is 3 times the volume of this cube, is 250 cubic meters. Statement B, the diagonal of the cube X is 24 meters. So using statement A alone, surface area of a cube Y is, let's say it has a side Y, so it will be 6y square. 6y square, whose volume is 3 times the volume of this cube, is 250 square meters. Sorry, it's not cubic meters, square meters. So we're talking about surface area, okay? Surface area is 250 square meters. That's what it says, okay? So, so 6 times y square is 250. So from that we solve for y, which is the edge of the length of the edge of the bigger cube y. And we know that the volume of this cube is 3 times the volume of the smaller cube X. So we know the edge of the bigger cube Y, and from that you calculate the volume, and that is 3 times the volume of the smaller cube. So from that we know the volume of the smaller cube, and from that you take the cube root of that, we know the length of the edge of the smaller cube, right? So we solved for, using statement A alone, we can calculate the edge of the cube x. So using statement B alone, the diagonal of the cube x is 24 meters. So the diagonal of a cube, what is it? So say x squared plus x squared plus x squared, that's 3x squared, and you take the cube root of the square root of that. So it's square root of 3 times x. So that is 24 meters. So directly you can calculate x. So either statement alone is sufficient. So we pick option 2. Question 43. In how many days will 3 women complete the work? Statement A. 4 men can complete the work in half the time taken by 12 women to do the same work. Statement B. 2 men complete half the work in 7 days. So using statement A alone, we can determine 1 man is equivalent to how many women? 4 men can complete the work in half the time taken by 12 women. So clearly 2 men can complete the same work in the same time taken by 12 women, right? So, or for using this statement, you get a relationship between the number of men and women, the time taken to do the work, ratio of how much time a man takes to how much time the women takes. So half the time taken by 12 women is nothing but the time taken by 6 women, right? So 4 men do the same work as 6 women. So 2 men do the same work as 3 women. Okay, so we got the relationship straight away. Or 1 man can do the work, same work as takes the same time as like 3 by 2. For doing the same amount of work, you can either use 1 man or 3 by 2 women. So that's what it means. And but it's not enough to say how many days will 3 women in how many days 3 women will complete the work. Using statement B alone, so 2 men complete half the work in 7 days. So we clearly know that 1 man can complete the work in 14 days. So from this we know exactly how much time 1 man takes to complete the work. So in this statement A, we just know the ratio of time taken between men and women, but we don't know how many days they take to complete the work. But in the statement B, we know exactly how much time 1 man takes to complete the work. So using both the statements together, we can say how much time 1 woman will take to do the work, and from that we can calculate how much time 3 women will take to do the same work. So we pick option 3. Both the statements are required to solve the problem. We don't have to sit and calculate the numbers and find the exact answer. All you have to say is if both the statements are required or either statement alone is enough. So question 44. What is the acceleration of the car? Statement A. The car covers 20 kilometers in 30 minutes. Statement B. The car speed increased uniformly by 3 kilometers per hour every minute. So using statement A alone, we can only know the average speed of the car. 20 kilometers in 30 minutes. So that's like 40 kilometers in 1 hour. So the average speed of the car is 40 kilometers per hour. That's all we can infer from statement A. We don't know the acceleration. It might have gone faster, slow, faster, slow. I mean, we don't know. And we don't know if even if it was, say, uniform acceleration, we just know the average speed of the car, okay? It might have gone faster and slow, faster, slow. We don't know, right? Because it doesn't say uniform. And using statement B, the car speed increased uniformly by 3 kilometers per hour every minute. So clearly the acceleration is directly given here as 3 kilometers per hour. So it's like 3 kilometers per 60 minutes. And divided by every minute. So speed divided by time is acceleration. So directly it gives you here. So statement B alone is sufficient. Pick option 1. But statement A alone is not sufficient. Question 45. What is the total cost of 3 tables and 4 chairs together? Statement A alone. Cost of 2 tables and 3 chairs together is $150. Statement B alone. Cost of 5 tables and 4 chairs together is $280. Using statement A alone. So 3t plus 2t plus 3c equals 150. And using B, we can have multiple values for t and c. You can't get unique solution. But using B alone, 5t plus 4c is 280. So you can have multiple values here again. But using both the statements together, we get a unique value of number of cost of each table and cost of each chair. So both the statements together are sufficient. So we pick option 3. Question 46. Jack and Jill purchased foreign currency to travel to Thailand. How many Thai baht did they get? Statement A. The conversion rate on that day was $1 equals 32 Thai baht. So Thai baht is the currency of Thailand. So statement B. Jack converted $100 into Thai baht and Jill got 1600 Thai baht after conversion. So let's say using statement A alone, we know the conversion rate, but we don't know how much currency they converted into baht, right? But using statement B alone, Jack converted $100 into Thai baht and Jill got 1600 Thai baht. After she gives X amount of dollars, she got 1600 Thai baht. But we don't know the conversion rate. So using both together, we know how many dollars they converted and how many Thai baht they got. So we pick option 3. Question 47. An equilateral triangle is inscribed in a circle. So the circle and an equilateral triangle is inscribed inside the circle. What is the difference between the area of the circle and the equilateral triangle? So the circumference of the circle is 68 centimeters. Statement A. Statement B. The height of the equilateral triangle is 13 centimeters. So draw a picture for your own reference. So using A, the circumference of the circle is 68, so 2 pi r is this, and so you calculate the radius of the circle. From this we know the radius of the circle. So there is a circle and an equilateral triangle inside it. Okay, so what is the height of that equilateral triangle? So the radius of the circle is nothing but 2/3 of the height of the equilateral triangle. That's geometry, refresher geometry. So the radius, so you have like a circle here and a triangle inside it, and there's the height of the triangle. So you make a 2/3 part and then you draw lines like this, they'll be equidistant. So you'll have the radius is nothing but 2/3 of the height of the equilateral triangle. So from this we know the height of the triangle, and once you know the height of the triangle, equilateral triangle, you can determine the length of the side of the triangle, right? So it's an equilateral triangle and we know the height. So from that we know that the height bisects the base, right? So we have say half of the base here and then one of the edges here, which is double the half of the base, and then we know the height. So from that you just plug in the values and you'll be able to solve for the length of the side of the equilateral triangle. And from that you calculate the area of the equilateral triangle. So we know the area of the circle and we know the area of the equilateral triangle. You subtract them and you get the difference. So I'm saying it's possible to solve it using statement A alone. Don't waste your time plugging in values and solving it. Just think about, is it doable? Is it solvable using A alone or not? It's solvable. So that's all we need to know. And then using B, we calculate the side of the equilateral triangle and its area. The height of the equilateral triangle is 13 centimeters. So we know the height of the equilateral triangle, and 2/3 of the height of the, from that we can calculate the area of the equilateral triangle. And from the radius of the circle is nothing but 2/3 of the height of the equilateral triangle, 2/3 of 13. That's the radius of the circle. And so because the triangle, equilateral triangle is inscribed in the circle. So we know the radius of the circle, we calculate the areas of the circle. So height of the equilateral triangle, so we calculate the radius and this thing. So we, using either statement alone, we can solve for the area of the circle and the area of the equilateral triangle, and we can get the difference. So either statement alone is sufficient. So we pick option 2. Question 48. So 3 trans X, Y, and Z distributed $2,400 among themselves. How much did X get? So these are classic problems, okay? There's X amount divided between 3 or 4 friends. You have to calculate how much each one gets. So statement A, X and Y together get 5/8 of the total amount, and X got the same amount as Z. Statement B, Z got $900 as his share. Using statement A alone, X plus Y got 5/8 share. So what did Z get? 1 minus 5/8, that is 3/8 of the share. X is equal to Z. So Z got 3/8, so X also got 3/8. So what is 3/8 of 2,400? That is 900. So statement A alone is sufficient to calculate how much X got. Using statement B alone, we know that Z got $900, but we don't know how much X or Y individually got, right? So B alone is not enough, but A alone is enough. So we pick option 1. Question 49. What is the speed of the car? So statement A, speed of the car is twice that of the boat in water. Statement B, the water in the lake offers resistance to the boat, reducing its speed by 20%. If the boat was traveling on land or air with negligible air resistance, its speed would be 60 kilometers per hour. So using statement A alone, we don't know the exact speed of the boat or the car. We only know that the car is twice as fast as the boat. Using statement B alone, we can calculate the speed of the boat in water as 80% of 60. So the water in the lake offers resistance to the boat, reducing its speed by 20%. So if the boat was traveling on land, its speed would be 60 kilometers per hour. But if the boat was in water, it's reduced by 20%. So it will be 80% of 60. That's 48 kilometers per hour. So we know the speed of the boat in water, but we wouldn't know the speed of the car using B alone. But using both, we know the speed of the boat is 48 kilometers per hour and the speed of the car is twice of that. So we can calculate the speed of the car. So you need both the statements. So we pick option 3. So question number 50. What is the speed of the bus? Statement A. The speed of the car is 40% more than that of the bus, and the car takes 1 hour less than the bus to reach the destination 50 kilometers away. So speed of the car is 1.4 times the speed of the bus, and the car takes 1 hour less than the bus to reach a destination 50 kilometers away. So if the bus takes t amount of time, car takes t minus 1 hour t number of hours. So a car takes t minus 1 number of hours, bus takes t number of hours, and they reach the destination 50 kilometers away. So clearly, if you substitute c equals 1.4b, so you can solve for t right here, right? We can solve for t, and from that we can calculate the speed of the bus and the speed of the car. So it's clearly statement A alone is sufficient. Let's look at statement B. If the speed of the bus is increased by 20% and that of the car is decreased by 30%, so the speed of the bus will be 5 kilometers per hour greater than that of the car. So speed of the bus increased by 20%. So 1.2b. Car is 30%, 0.7c. then so the difference will be 5 kilometers per hour. So using this alone, it's not sufficient, but A alone is sufficient. So we pick option 1. Question 51. How much does Jack weigh? Statement A. Tom and Peter together weigh 4/3 of Jack. So statement B. Peter is 2/3 of the weight of Tom, who weighs 90 kilos. So using A, Tom plus Peter is 4/3 of Jack. And we can't solve for either of their weight individually. Using statement B alone, Peter is 2/3 of the weight of Tom, and Tom is 90 kilos, so Peter is 60 kilos. So from this we get the weight of Tom and Peter, but we don't know the relationship between their weight to Jack's weight. So using both the statements together, we can solve for Jack's weight. So we pick option 3. We need both the statements to solve this problem. Question 52. X, Y, and Z invested different amounts each as partners in a business for 1 year. At the end of the year, the company went bankrupt. Look how much did X lose? X invested twice the amount that Y invested. Statement B. Z invested 40% of the total amount. So using statement A alone, we cannot. X invested twice the amount that Y invested. Okay. So X, Y, and Z invested different amounts as partners for 1 year. End of the year, the company went bankrupt. How much did X lose? So X invested twice the amount Y invested. We don't know how much Z invested. So how much did X lose? We can't determine that. Using statement B alone, Z invested 40% of the total amount. So X plus Y invested 60% of it, and then X invested twice of that. So 3Y is 60%, so Y invested 20% and X invested 40% and Z invested 40%. So using both, we still don't know the exact amount. We don't know how much they invested, right? We know the percentages, but we don't know how much amount they invested. So clearly, using both, we still don't know how much loss they suffered. So we pick option 4. Both the statements together are insufficient. So question 53. How are Jack and John related? Statement A. Jack's aunt is the only daughter of her parents, and she has only one nephew. Statement B. John has a son and a daughter, and John's son has only one son. So using A or B alone, let's try. Jack and John, we are trying to find the relationship, right? Jack's aunt, so she could be mother's sister or father's sister. Jack's aunt is the only daughter of her parents, and she has only one nephew. So basically, she's probably like a step aunt or something. She's the only, oh no, she's an aunt. So she's the only daughter of her parents. So basically, Jack's aunt is the only daughter. So she cannot be the mother's sister, right? Because then she would have a sister and the parents would have two daughters at least. So Jack's aunt can only be a paternal aunt. She is the father's sister. That's the only possibility, right? So Jack's father's sister, the aunt, is the only daughter of her parents. But clearly they have at least a son who is the father of Jack. So we know she is the paternal aunt. And she is the only daughter of her parents. And she has only one nephew. So Jack is the only nephew. She may have a lot of nieces, we don't know. So, and she might also have other brothers who don't have children. So we don't know that either. So using, we don't even know who John is from this, right? So using statement B alone, John has a son and a daughter, okay? And John's son has only one son. So John's son has only one son, but we don't even know if John's son is Jack. I mean, for all you know, these statements have absolutely no correlation to each other. So John's son and daughter may be a completely different family. Jack's aunt is maybe a different family. They're not even like related here. So using both the statements together, we still can't say how Jack and John are related. So we pick option 4. Both the statements together are insufficient.